Determine the mass flow rate of smoke for an axisymmetric plume with the following parameters, and we've also asked you to compare it with SIBSE Guide E. Now the fire size is 4.5 metres by 3 metres, and your convective heat output is 6,000 kilowatts, and the clear layer height is 23 metres. Again, we know it's an axisymmetric plume, but you've got to work out, is it near field or a far field model? And the rule is, if the clear layer height is greater than the longest dimension of the source, the longest dimension of fire, multiplied by 5, then it's deemed to be a far field model. If not, it's a near field model. In this case, the clear layer height is 23 metres. Now 5 times the longest dimension of the source is 5 times 4.5 is 22.5. In this case, the clear layer height is greater than 5 times ds, so it's a far field model. And you'll be using this model here. This is the axisymmetric far field plume. M smoke equals 0.071 times QP to the third times Z minus ZO to the 5/3. Now in this case, you need to work out what ZO is first, which is the virtual source, and you're going to use this formula. ZO equals minus 1.02 ds plus 0.083 times QP to the 2/5. If you'd have put the known variables in this formula, you'd have got a ZO of minus 1.8964. That's what you'd have got, minus 1.8964. Now you put the ZO in the formula, you should have got this, an M smoke of 273.86 kilograms a second. That's the mass flow rate of smoke using that model. Let's compare this to SIBSE, where SIBSE classifies ZO as 0. In this formula here without the ZO, if you'd have put them in the known variables, you'd have got an M smoke of 240 kilograms a second. So let's compare 273.86 to 240. You're looking at a 13% decrease. Now that is quite significant. It just shows you a 13% decrease.